Hello everyone, my name is Mary Joy Intan, and for today's video, I am going to discuss the principle of rectilinear motion in the dynamics of rigid bodies. So what is rectilinear motion? So it refers to the motion of a rigid body along a straight line. In the context of dynamics, this involves the study of forces and their effects on a rigid body as it moves in a straight path, as well as the associated kinematics and kinetics. So the key principles governing rectilinear motion in rigid body dynamics are: first is the Newton's second law. So in the context of a rigid body moving along a straight line, the net force acting on the body is proportional to the acceleration produced. This is given by F is equals to ma. So where F is the net external force acting on the body, the m is the mass of the rigid body, and the a is the acceleration. This law forms the basis for understanding how a rigid body accelerates or decelerates along a straight line when acted upon by external force. And then the second is the kinematic equations. So the kinematic description of rectilinear motion in dynamics involves the relationship between displacement, velocity, and acceleration. So for a rigid body moving in a straight line, these equations are: velocity is equals to initial velocity plus acceleration times time. And then the next one is the S is equals to initial velocity times time plus 1/2 times the acceleration times the time squared. And then next is the final velocity squared is equals to initial velocity squared plus 2 times the acceleration times s, where s is the position. So these equations help in determining the velocity, position, and time of a rigid body in rectilinear motion. So the next one is the work energy theorem. So the work energy principle is useful in analyzing the motion of rigid bodies under a net force. So the total work done by the net force on the rigid body is equal to the change in its kinetic energy. So this principle can be used to relate forces acting on the body to its motion, especially when acceleration is not constant. And then the next one is the impulse momentum principle. So the change in the momentum of a rigid body due to the application of a force is equal to the impulse provided by that force. In the study of rigid body dynamics, one of the fundamental types of motion is rectilinear motion, which describes the motion of a rigid body along a straight line. A rigid body is defined as an object that does not deform under the action of external forces, meaning the distance between any 2 points on the body remains constant. When analyzing rectilinear motion, we focus on the forces acting on the body's mass, and how these lead to linear acceleration. Understanding the principles of rectilinear motion is crucial for designing mechanical systems, analyzing the motion of vehicles, and studying the behavior of objects in motion under gravity or other forces. So we have here a problem. A car starts from rest and accelerates uniformly at 2 meter per second squared for a time of 5 seconds. Calculate the distance traveled by the car during this time and its final velocity. So, we will start it by listing all the given from the problem. So, the given, we have initial velocity of 0 meter per second since the car starts from rest. And then we have next acceleration of 2 meter per second squared. And the next we have a time of 5 seconds. So, to find the distance traveled, we are required to find the distance traveled by the car during this time and its final velocity. So, to find, we have distance traveled S. And then the final velocity. So, finding the distance traveled, the formula for the distance traveled under uniform acceleration is given by we can use the kinematic equation S is equals to velocity times time plus 1/2 AT squared. So, from the given problem, we can direct substitute all the given from the equation. So, we are finding the distance, which is the S. So, S is equals to the velocity, initial velocity, which is 0 times the time, 5 seconds, plus 1/2, and then the given acceleration is 2, so 1/2 times 2 times the time, 5 squared. So let's calculate. We have, so 0 times 5, we can cancel this out. So 1/2 times 2 times 5 squared. So we have 25, a distance of 25 meters. And then we have now the distance. So the next, we will find the final velocity. So in finding the final velocity, we can use the V velocity is equals to final velocity is equals to initial velocity plus AT. So since we have already given 0 meter per second for the initial velocity, we also have the acceleration, and we also have the time, we can directly substitute it. So final velocity is equals to, since the initial velocity is 0, so plus the acceleration of 2 times the time of 5. So 0 plus final velocity is equals to 0 plus 2 times 5 is 10 meter per second. So we have now our answer. So this is the distance traveled by the car during this time, and this is the final velocity. So next problem. A motorcycle starts from rest and accelerates uniformly at 4 meter per second squared for 6 seconds. Find the final velocity of the motorcycle after 6 seconds. Second, find the total distance traveled during this time. So let's read it again. So a motorcycle starts from rest and accelerates uniformly at 4 meter per second squared for 6 seconds. So find the final velocity of the motorcycle after 6 seconds and the total distance traveled during this time. So let's write the given data. So the given, we have initial velocity of 0 meter per second since it starts from rest. The acceleration is 4 meter per second squared. And then we have the time. We have the time of 6 seconds. So we are going to find the final velocity of the motorcycle after 6 seconds. So using the equation of motion, the final velocity is equals to initial velocity plus plus acceleration times time. So we have here the final velocity, the initial velocity, which is 0, given 0 initial velocity, plus the given acceleration of 4 times the given acceleration of time 6. So since 0 plus 6 times 4 is 24, the final velocity is 24 meter per second. So this is our final velocity. And the next, we are tasked to find the total distance traveled during this time. So since it is the distance, we will use the distance is equals to initial velocity times time plus 1/2 acceleration times time squared. So the distance, so initial velocity of 0, so we have the time of 6 plus 1/2 the acceleration of 4 and then the time of 6 squared. So let's calculate it. So 0 times 6 is 0, so S is equals to 1/2 times 4 times 6 to the power of 2 equals to 72 meters. we have here 72-meter distance. Let's proceed to another question again. A car traveling at 20 meter per second decelerates uniformly at 5 meter per second squared until it comes to rest. Find the time takes for the car to stop. And then next, the distance it travels before stopping. So a car traveling at 20 meter per second decelerates uniformly at 5 meter per second squared until it comes to rest. Find the time takes for the car to stop and the distance it travels before stopping. So the first one we will find the time, and then the second one we will find the distance. So the given data, we have initial velocity of 20 meter per second. And then the final velocity of 0 meter per second, since it will decelerate. And then the acceleration is negative 5 meter per second squared. So, negative 5 meter per second squared in the acceleration, because the 5 meter per second squared is from decelerates uniformly. So, decelerates uniformly at 5 meter per second squared. And if it will decelerate, the given will be negative. So using the equation of motion again, we will get the time. So we have here given initial velocity, and we have also the final velocity and acceleration. So we can use the equation v is equals to velocity is equals to initial velocity plus acceleration times time. So we will just substitute all the given, and then final velocity is equals to since initial velocity is 20 plus the acceleration of negative 5 and then the time. So the final velocity is 0. So this is 0. So the time is, we will calculate it, 0 plus negative 5 so the time is 4 seconds. The car takes 4 seconds to stop. Next, we have to find the distance it travels before stopping. So the distance travel, since we will find the distance, we can use the equation S is equals to initial velocity times time plus 1/2 times the acceleration times the time squared. So since we will find the distance is equals to, since we have initial velocity of 0 times that we are finding the time plus 1/2 times the acceleration of -5, and then we will find, the time is 4 seconds. So 0 times 4 plus 1/2 times the acceleration of -5 times the time of 4 to the power of 2. So S is equals to, we will calculate it. 0 times 4 will be cancelled. So 1/2 times -5 times 4 to the power of 2 is equals to 40 meter. We have 40 meter distance before stopping. Okay, so next problem, we have a car starts from rest and accelerates uniformly at 2 meter per second squared for 10 seconds. Then it travels at a constant velocity for 20 seconds, and finally decelerates uniformly at 1 meter per second squared until it comes to a stop. Find the total distance traveled by the car, and second, the total time of motion. So, our problem is a car starts from rest and accelerates uniformly at 2 meter per second squared for 10 seconds. Then it travels at a constant velocity for 20 seconds and finally decelerates uniformly at 1 meter per second squared until it comes to a stop. So find the total distance traveled by the car and the total time of motion. So how can we solve this one? We can solve this one by step 1 is to analyze the motion. So the motion can be divided into 3 phases. So we can divide it by 3, which is ang acceleration phase. So the car accelerates uniformly from rest. So a car starts from rest. And then the constant velocity phase. So the car travels at a constant velocity. So ikaduha, number 2. So the car travels at a constant velocity. And then the third phase is the deceleration phase. So the car decelerates uniformly at rest. I mean, the car uniformly decelerates at 1 meter per second squared. The car decelerates uniformly to rest. So next we will calculate So step 2, we will now calculate each phase. So as we said earlier, the first phase is the acceleration. So we will find the acceleration. So using the equations of motion, the velocity is equals to initial velocity plus acceleration times time. So we have here the given initial velocity, which is the car starts from rest. So since the car starts from rest, the initial velocity is 0. So v is equals to 0 plus the acceleration, 2 meter per second squared, and the given acceleration and accelerates uniformly at 2 meter per second squared. So the acceleration is 2 for 10 seconds. So we have the time 10 seconds. So we have now v velocity is equals to 20 meter per second. So to find the distance traveled during acceleration, since we have now the final velocity of 20 meter per second, we can find the distance traveled during acceleration by using the equation S is equals to initial velocity times time plus 1/2 times acceleration times time squared. So, since we are finding the distance, S is equals to initial velocity is 0, and then we have the time 10 plus 1/2, and then the acceleration of 2 meter per second squared, and then the time again squared. So we will calculate it. So 0 times 10, 0. So 1/2 times 2 times 10 to the power 2 is, we have an answer of 100 meter. So next we have the phase 2, which is, as we said earlier, the constant velocity. So the velocity during this phase is 20 meter per second. And the time is 20 seconds. So we have here the 20 meter per second and then the time of 20 seconds. So we will use the equation S is equals to velocity times time, since we have now we have given velocity and then we have a given time. So S is equals to 20 times 20. So 20 times 20 is 400. So we have now the answer of the second phase, the 400 meter distance. So we have now the distance of 400 meter. And then the last phase, we have here, so the deceleration. We will calculate the deceleration phase. And then using the equations of motion again, we have final velocity squared. We can use this one. And then initial velocity squared plus 2 times acceleration times the distance. So since the third phase is the finally decelerates uniformly at 1 meter per second squared, since the car comes to rest, so the velocity is equals to 0 since it will come to rest. So by substituting, we have 0 is equals to we have the initial velocity of 20 squared plus 2, and then the acceleration, the given acceleration is, since it will decelerate, we have 1 meter per second squared, it will be negative 1. So we have our required to find the distance. So we will write the s. And then we will calculate it. So 0, 20 squared plus 2, negative 1. I'm sorry guys, the video stopped. So let's continue. So here we have 200 meter distance. So we have already the value of the third phase distance, so which is 200 meter. So next we will have to find the time taken to decelerate. So we can use the equation. Final velocity is equals to initial velocity plus acceleration times time. So we have a given velocity of 0 is equals to 20, the initial velocity plus the acceleration, which is negative 1. Why negative 1? Because it decelerates. So we should put negative 1 and then the given, the time we need to find. So time, so we will calculate it. So 0, 20 plus negative 1 times the time. So we have a time of 20 seconds. So now we will find the total distance traveled by the car and the total time of motion. So the total distance, we will write it here. So to find the total distance, we are going to add all the distance we found. So S total is equals to, we have the 100 plus 400 plus 200. So 100 plus 400 is 500 plus 200 is 700 meter. And then the total time, we have that 10 plus 20 plus 20 is equals to 50 seconds. 10 plus 20 is 30 plus 20 is 50 seconds. So here is the final answer. This is the total distance, and then this is the total time.